Welcome to today's feature of the week, which continues the series on uncertainty in Simulx. In a previous feature of the week, number 124, I have explained how to perform simulations taking into account the uncertainty of the population parameters by using the element MLXPOP uncertain SA or MLXPOP uncertain lin. This element considers the uncertainty on both the fixed effects and the standard deviation of the random effects. But sometimes we would like to just simulate a typical individual and check the impact of the population parameter uncertainty on these predictions. So today I will show you how to do that. Simulating a typical individual actually means setting the random effects here to 0. And in terms of population parameters, this means setting the standard deviation of the random effects, the omegas, to 0. So the goal here is to take into account the uncertainty on the fixed effects, but ignore completely the random effects. There is no element created automatically in Simulx to do this, so we will have to do a few manual steps. So the steps consist in first generating a set of population parameters using MLXPOP uncertain element, then post-processing this output file outside of Simulx to set the omegas to 0, and finally creating a new pop-prime element in Simulx from an external using this modified file. So let's check these steps one by one in the graphical user interface. I will first import a MonoX project. And the first step now is to do a dummy run just to generate the population parameter file. So to do this, I can directly go to the simulation tab, and I will set the number of replicates, which will be the numbers of sets of population parameters I will sample from the uncertainty distribution. For the parameters, I need to select MLXPOP uncertain SA, and the rest can actually be left by default because in this step, my only goal is to generate sets of population parameters. And everything that happens downstream, so sampling the individual parameters, running the simulation, etc., I won't use it, so I don't care about it. However, just to speed up the simulation, I can set number of individuals equals 1. I'm going to save this project to somewhere I can access easily, and I'm going to call this generate pop param. When I click on run, Simulx will sample 100 sets of population parameters from their uncertainty distribution, save them to a file, and then for each of these replicates, sample one individual. What I'm going to do is to go to the result folder using this button, and here in the simulation file, I have the file population parameter.txt, which is the one I would like to modify. So I'm going to open it, and it looks like this with one line per replicate. And here what I need to do is to first set the omegas to 0. So this is the main change. And then there is another change I can do, is that the columns rep and group are actually useless when I'm going to import this file into Simulx as an external file to define the pop-param element. If I leave rep and group, it's going to generate a warning, but which is okay, it's just a warning. If I would like to avoid the warning, I'm going to also delete these two columns, rep and group, so that I just have columns corresponding to the population parameters with the omega, so the standard deviation of the random effects set to 0, such that I will just simulate a typical individual. I now need to save this file, and it's important to save this file at a location where I can find it easily. So actually I will save it in my working directory, and I will call it pop-param sets, for instance. Now I go back to Simulx, go to the definition tab, and create a new population parameter element, which I will define via an external file. So here I'm going to select the file I have saved previously, and I'm going to call this pop uncertain fixed effects, and click OK. And if we have a look at this element, we can see that we indeed have different sets of population parameter values for the fixed effects, so T lag pop, Ka pop, V pop, Cl pop, and the error model parameters, but 0 for the omegas. Then I go to the simulation tab, and here for the parameters, I'm going to select the elements that I've just created before. I need to keep the replicates as they were before. So this means that I'm going to run the simulation 100 times. For each of these 100 simulation, I'm going to use one line of this external file as population parameters. I will also keep group size equal 1 because there is no inter-individual variability as the omegas are 0. So actually all individuals within a given replicate will be the same. So I need to simulate only one. So now that everything is set up, I can click on Run. And in the plot, I can see that in this example, the prediction interval is quite narrow, so a typical individual has quite few uncertainty. So if we recap the different steps, we first import a MonoX project. Then we defined first a dummy run to generate n sets of population parameters from the uncertainty distribution with uncertainty on all parameters. So to do this, we select MLX pop uncertain. We set the number of samples we want to get and group size equal to 1. This generates this file here, which is a text file that I need to modify outside of Simulx. The main step to modify it is to set all the omega values to 0. And optionally, you can also remove the rep and group columns. And then we create a new population parameter element in Simulx from an external file using this modified population parameter.txt that I have saved in a location that is easy to find. So don't leave it in the result folder of your dummy run. That's not convenient. And finally, I select this new population parameter element in the simulation tab to run my simulation, taking into account the uncertainty on the fixed effects only. Have a nice week.